we're going to look at some of these here, writing summation notation. Now, when we look at this here, so we're going to look at this here first. So writing a series or sequence in summation notation is just this here. So summation is this here, this E looking thing. And what we're saying is the sum of all the numbers in the sequence or series. We're adding them together. So for the finite series, it'd be helpful if I had a pen. Here, so 2, 4, 6, 8, if we're going to add all those together, we can write it as the summation from I equals 1 to 4 of 2i. So we're just adding those together. So 2, 4, 6, 8 is what it's telling us. Now, that's specifically going from the first term to the fourth term. We're just looking at the first 4 terms. Now, if we say from I equals 1 to infinity, we're talking about the infinite series. We continue it on indefinitely. And for this here, it's actually going to equal infinity. Because as we keep adding more and more terms to it, the numbers are going to keep getting bigger and bigger and expanding indefinitely. It's just going to keep expanding on and on forever. Now, not every sequence and series will do that. Some are considered convergent. They're going to go to a certain point. It's going to go to a spot, a number. It converges or is convergent as it is approaching a point, a fixed location. Divergent is going to go off forever. Convergent goes to 1, divergent goes off. Does that kind of make sense? Or we talk about something not being convergent, it's just going out, expanding indefinitely. And this is kind of how we set it up. But for us to be able to do the summation of a finite or infinite series, we need the rule for it. So if we look at this here, if we're going to write this in summation notation, well, we do have a starting point and we do have an official ending point. Going from one term to the next, we are adding 25 to it. Or the rule for this here, for a sub n, is going to be 25 times n. Because if n is 1, we get 25. If n is 2, 25 times 2 is 50. That's our second term. 25 times 3 is 75. So we do get our terms, yes? So this would indeed be the first, this would be the second, this would be the third. And then we have a bunch in between. So what term would be 250? What times 25 is 250? So we have the summation of the first 10 terms, yes? So to write this, we would say the summation. So the way I draw it is I do a line, over, down, over, to make this E. Right next to it, we would have 25 N. I use N. We could have used I, because the way that the book uses it is as I, but that's fine. And on bottom, instead of using I, we say N equals 1. That's our starting point. Now, some series or summation notation will start at 0. We could start at 0. We could start at 1. It just depends on where we want to start. And here we're going to 10. So this sequence, or this summation in summation notation, would be the summation of n equals 1 to 10 of 25n. And that's it. Questions on this here? Now, if we look at the next one here, it goes off infinitely because we have the plus dot dot dot. It doesn't have an n number. But we do need the rule for this. And this rule here should look familiar. It's similar to what we've had before. Now the numbers on top of the fraction are increasing by, so I could say that it is n. And the reason I say n and not n plus 1 is kind of based off the term in the sequence. Because 1/2 is our first term, 2/3 is our second, 3/4 is our third, 4/5 is our fourth. The number on top matches the term. So we can just say n. However, the numbers on bottom are one more than our term, yes? Plus 1. So now we can do our summation. What goes next to it is our n over n plus 1. And we're starting out at n equals 1, because that's our first point. And where are we going to? What is our number in the sequence that we're ending at? Infinity. We're not ending. It just continues on indefinite. So we would put infinity above it. And that there would be our summation notation. Questions on this here? And there's a good chance this is convergent. I would have to look that back up because there is a way to determine if the sequence is convergent or divergent. Most likely, especially if it's whole numbers, like 25, the last one we had, that's divergent. It's going to keep getting bigger. Any questions on these here? And that's really all we're going to do with this here, because I want to show you it so you've seen it, you kind of have a feeling for it, but that's about it. And we could do others with it, writing rules. What I want to do next is find the summation of this here. We want to find out what it actually is. And we say the summation from k equals 4 to 8. That means we're going to take our terms, I'd say that's a little bit better, yes? And that blurry screen really does, it's hard to look at. But what we're going to do is replace each k into it. So the first one we would replace is, or plug in is, what? 3 plus, what number squared? 4. Because all the ones so far we started with 1. So we, on the bottom we wrote k equals 1 or n equals 1. So the first number we have is 4. The next one would be what? 5. The next one would be? The next one would be? 7. The next one would be? The next one would be? Because where are we going to? 8. Because the number below the e, our summation is the starting point. The number above it is the ending point. And if we put the number above it as infinity, it's going to continue on indefinitely. Now we just have to add them together. Now at this point here, if we wanted to type all this into the calculator and let it do it for us, we could. So here, if we did this by hand, well, 4 squared is 16. 5 squared is 25. 6 squared is 36. 7 squared is 49. And 8 squared is 64. Now we add these together, so that'd be 19 plus 28 plus 39 plus 52 plus 67. Now we can add these together. I'm going to do 19 and 28, which is going to be 47. 39 and 52, 191 plus 67. Here we get 138 plus 67 5, carry the 1. 0, carry the 1. 205. Questions on this here? Because, I mean, at the beginning, we could have done parentheses 3 plus parentheses 4, close parentheses squared, close parentheses, and just type the whole thing out, hit enter, and it would have done it for us. Questions on this here? Huh? Now, this one here is divergent if we'd have kept going, because we keep adding bigger and bigger numbers to it, so it's not going to have a point where it just reaches a number, because if this went to infinity, instead of 8 we put infinity, the sequence itself would go to infinity. It would just get exponentially bigger. Not exponentially, but it would get bigger. Find the sum of, from k equals 3 to 9, of 4k minus 1. So we start out with 4 times 3 minus 1, plus 4 times 4 minus 1, plus 4 times 5 minus 1, plus 4 times 6 minus 1, plus 4 times 7 minus 1, plus 4 times 8 minus 1, plus 4 times 9 minus 1. And then we can work this out here. 4 times 3 is 12. 4 times 4 is 16. 4 times 5 is 20. 4 times 6 is 24. 4 times 7 is 28. 4 times 8 is 32. And 4 times 9 is 36. Any questions on this so far? We feel pretty comfortable with this so far, yes? Now we got to add these together. I'm going to be a little particular with this just because I want to make addition, subtraction easier, if I can make it easier, yes? So normally we would go 11, 15, 19, 23, 27, 31, and then add 35 into the group later, yes? What would 23 plus 27 be? 50. Because we get some nice numbers there, yes? How about 19 and 31? 50. 15, 35. 50. 11's all out on his own. Well, we can do 50 plus 50 plus 50 is... Because if I find nice pairs that work together, might as well use those and add them together. Questions on any of this here? Not too bad so far. Now, for special series have a summation to them. So, to find the sum of n terms of 1, we're just adding 1 to itself. It's just whatever the summation is. So if we said from 1 to 100, it would just be 100. Now, if we're looking for the sum of the first n positive numbers, so looking at 1, so if we had 1 plus 2 plus 3 plus 4 plus 5, going all the way to 100, we could actually use this formula here, n times n plus 1. So we could say 100 times 100 plus 1 all over 2. 100 times 100 plus 1 over 2. So that'd be 100 times 101 over 2. What's 100 divided by 2? And 50 times 101 is, we have 0, 5, 0, 5. 5,050, yep. And this makes sense. If we look from just the positive integers, from 1 to whatever the number is, we have n times n plus 1 divided by 2. Because the first number from 1 to 100 would be 1, yes? The last number is 100. Yep. So what I'm doing here is I took all the numbers from 1 to 100 and I folded it in half. Because what is 1 plus 100? 101. The next number after 1 is 2. And 99 is? Because if I fold it in half, we have 1 and 101, 2, 99, 3, 98. And it would continue this pattern, yes, all the way up to 50 and how many of these would I have? Well, I folded it in half, yes? So if we had 100 numbers, I folded it in half. How many do we have? So I can take 101 times 50 and get the sum. And that's essentially where the formula came from. Because we have the number total times 1 more than it divided by 2. For squares, n times n plus 1 times 2n plus 1 divided by 6. And that's all that's saying is if I took 1 squared plus 2 squared plus 3 squared plus 4 squared, we can plug it into that formula there and get what it would be. There's actually one for cubes, too, in fourths. They have a special sum for them, but we have these here. Okay. We ready to look at the next one? Yes? So the first one we're looking at is the sum from 1 to 5 of 8 times I, yes? Math. I'm going to go up. Is there something there that looks useful? Summation is listed there, yes? So if I select this, we have this here, yes? Now, we can use I if we want. There's one that's a little bit easier to use. X, because we just hit that one button, it'll throw it in. We don't have to do alpha and then go find the letter. What number did we start with for our summation for this one here? 1, yes? So x equals 1 at the bottom, and it's going to of 8x is our summation, yes? Hit enter, it is 120.
So for all the variables, you can just use x.
Now, you may not like this, but if we think of the one we did earlier from 3 to 8 of 3 plus x squared. This is the first one we did, yes? Now the one we just did a minute ago, because we said the summation, not x squared, we just said of x, the top number was 100, and we started at 1, 5,050.
Interesting.
This might be,
Yeah.
so we can do the summation from 1 to 100 of x cubed minus x squared. It'll give it to us. Now, there are some cases, and I'm probably about to lock this thing up for a minute or two. Well, not so much lock it up, just 30. Okay. You can do that there. There's some of these I've done before. Let's add, let's say 10,000. There it is. Overflow. Essentially, the numbers got way too big for it to figure it out. Yeah, calculation exceeds the range of values the machine is able to display. So, now the homework is not all of this here. Because again, you already did 5 through 11. I'm marking all that out. So, I'm going to borrow this. Yeah, some of y'all did, Ramsey. You're having fun with this.
Oh, wow. Well, that's good. That's what it said yesterday.
39 through 46.
I could read through it. It's okay.
Yep. And that's all you're doing for that there. But that's it.